Good morning, students. Welcome back. Today we'll be discussing about another white box testing technique, that is mutation testing. Right? Mutation testing is the process of mutating some segment of code, putting some errors in the code, and then testing this mutated code with some test data. Exactly what is this? What is mutant actually? Mutant is some changed form, mutant. Right? Biology, if you have studied, you must have easily recognized this term. Say you have a particular code, right? You test it, you identify the errors, and you modify your test cases, right? But what tester exactly does, what is his task, is to identify maximum possible errors. Along with that, you have to enhance your test cases also, so that in future any new error comes in that case also your test cases are efficient enough to identify that new error also. So how it is done is, before deploying the system, what we try to do is we artificially induce error in our system. Okay? So if you are artificially inducing the error, you are making mutants of your program by making changes in say one line. Say you have a code which says a equal to this, b equals to this, equals to a plus b, d equals to a minus b, simply like calculator sort of thing. So one mutant will be that in c equals to a plus b, I'll write c equals to a plus a. This is a mutant, I have artificially induced a change. In second one, I'll say d equals to b minus b instead of b minus a. So this is how I am artificially making changes in my code. I am inducing an errors. Now I want that my test case, whatever I have developed, must catch this error or identify these errors. If my test case is efficient enough, it is able to identify this error which I have artificially induced, that means my test cases are proper. But if I am not able to identify that error, that means there is something, you can say test cases are not proper. You have to improve your test cases so that it can identify that error. So ultimately it's a process of enhancing your testing process, in turn your test cases, right? So if the test data is able to detect the mutations in the code, then the test data is quite good. Otherwise we must focus on the quality of test data. Therefore, mutation testing helps a user create test data by interacting with the user to iteratively strengthen the quality of the test data. Ultimately, you have to improve your test data. Now, how it is being carried out? During mutation testing, faults are introduced into a program by creating many versions of the program, each of which contain one fault. Test data are used to execute these faulty programs with the goal of causing each faulty program to fail. Faulty programs are called mutants of the original program, and a mutant is said to be killed when a test case causes it to fail. Right? While when this happens, the mutant is considered dead and no longer needs to remain in the testing process, since the fault represented by that mutant have been detected, and more importantly, it has been satisfied its requirement of identifying a useful test case. Thus, the main objective is to select efficient test data which have error detection power. The criteria for this test data is to differentiate the initial program from the mutant, and this distinguishability between the initial program and its mutant will be based on test result. Exactly, it's a process. This is how it is being carried out. Now we have two types of mutants. First is a primary mutant and second one is a secondary mutant. So when the mutants are single modification of an initial program with some operators, it is called as primary mutant. Like for plus, you can replace it with a multiply or a subtract sign. While when multiple levels of mutants are being applied on the same program, right, it is said to be secondary mutant. Now how the process constitute? Construct the mutant of the test program, add test cases to the mutation system and check the output of the program on each test case to see if it is correct. If the output is incorrect, the fault has been found and the program must be modified and the process restarted. If the output is correct, then the test case is executed against each live mutant. If the output of a mutant differs from that of the original program on the same test case, the mutant is assumed to be incorrect and is killed. After each test case has been executed against each live mutant, each remaining mutant falls into one of the following two categories. First one, the mutant is functionally equivalent to the original program. An equivalent mutant always produces the same output as the original program, so no test cases can kill it. Second, the mutant is killable, but the set of test cases is insufficient to kill it. In this case, new test cases need to be created, and the process iterates until the test case is strong enough to satisfy the tester. So the mutation score for a set of test cases is the percentage of non-equivalent mutants killed by the data. If the mutation score is 100, then the test data is called mutation adequate. So ultimately the process says make the changes, make mutants of your program, maybe primary or secondary mutants could be there. You apply your test cases. If they're able to detect it, it's well and good. You have an efficient test case, else you have to improve your test cases. So this is what mutation testing process says. So this is all for your today's topic. Rest will continue in the next lecture.